Good morning, good evening, wherever you're watching from. My name is Evaristus Ezekwem, and I'll be your guide in today's session. So today we'll be talking about executing machine learning projects at scale using Microsoft Azure. So before we dive into the topic, a little bit about myself. I'm a student of New York University Center for Data Science. Prior to now, I've, loved data science and technology as well. So most of the time, if you catch me doing one thing 60% of the time, it might be technology, gaming, or traveling, depending. And then you could follow me, you could shoot me an email, whatever. All right, so let's dive in. So this course is for you if you have built maybe one or two machine learning projects on your computer and you want to learn how to deploy it in production, or maybe you've heard about Microsoft Azure and you want to know how you could use that to deploy machine learning solutions. In this course, we're going to talk about all these things. All right, so let's start with what is Azure. So many people call it Azure, some call it Azure, some call it Azure, depending on what you hear. But Azure is Microsoft's public cloud offering. So you might have heard of other public cloud offering like GCP, AWS. There are so many cloud services out there. So, but for today's session, we're going to be using Microsoft's cloud offering, which is called Azure. All right. So before we continue, let's take a look at the different stages of building a data science and machine learning solution. But this approach is essentially not constrained to data science and machine learning. Pretty much any software project or technology project most of the time goes through this core building blocks, right? Some of them you delve in deeper, some it's a lot more elaborate than what you have here, but this should give you a general idea. So you have an idea of this application that is going to change the world. I'm sure everybody has had that idea at some point, and then you go ahead to, put something down, write it down, write out all the details of what the solution should do. And then the next thing, you try to build this thing by yourself on your computer. You build, you tested it, and you've done everything you can, and you feel it's ready to go. Now the next step is to put it out there for the world to use and try it out. So for today, we're going to be focusing on this part, the last part here, which is the deployment part. So in this deployment part, we're going to look at different scenarios and what exactly is involved when you're deploying not just any software solution, but a data science or a machine learning solution. So moving on, business case is going to give us an idea, because the whole idea of a solution is that there's a problem and your software or your data science solution are a problem. So let's look at a specific business problem, and then our project is going to, but I must warn you. So the business case you're going to see is a very practical business case, and it does not imply any political affiliation or thinking purposes. It is solely for learning. It shouldn't be misconstrued or for promoting or harming anybody's political beliefs or affiliations. So the reason I chose a political business case for this demo is because in the US right now, not just the US, but besides the COVID virus, right, everybody's talking about the US elections, both within the US and outside the US. So why not? Why not use it as a business case? Besides that, the next thing is coronavirus. And I don't want to talk about coronavirus today, but I already did that. All right. So moving on. So let's look at this case study. So you were recently hired by political party A as a data scientist to work on the party's campaign strategy for the upcoming US presidential elections. And then party A just officially elected its candidate, Mr. A, at a convention that ended this week. But also, an opposing political party B is likely to present Mr. B, although party B's convention is coming up next week. Since party A's convention ended, people across America and the rest of the world have been using Twitter to express their views about the two candidates. And just like the previous election, Party A knows that social media can have a huge influence on the outcomes of the election. So they want you to build a data solution to integrate social media views into the campaign strategy. To this end, the lead of the campaign organization, Mr. Z, wants you to build a dashboard that can meet the following needs of the party. He wants you to be able to fetch tweets in real time about Mr. A and Mr. B. He also wants to display the total number of tweets for each candidate. And then the dashboard should be accessible on both the web and mobile devices to allow other team members have access to the data. And then, additionally, Mr. Z believes that monitoring the sentiments of the tweets, especially those from the United States, will help the party get an edge over the opposition, and wants you to integrate this feature if it's possible. So this is what the party wants you to do. So in summary, you are to build a data solution that can capture tweets about two specific individuals and then present it to a team in a form of a dashboard report so that they can make campaign-driven decisions based on the data. So in summary, this is what you are supposed to build. And then you've sat down and you decide to come up with a design, right? So, but just as you're about to come up with your design, Mr. Z also told you that he's promising you a recommendation to work in the data division team of the White House if your sentiment analysis solution proves to be an integral part in helping Mr. A win the presidential elections. So this is more of a bonus point, right? So if you look at the requirements, the core requirement here is the technical requirement, these three things. Okay, so the additional requirement is fine if you could do it, but if you can't, that's okay. All right, so it came up with this design. Now, this is what your solution is supposed to do. And then I'm going to explain this design so that we have an idea what we're about to build. So the first thing we have here is the Twitter API. Now, remember that we are fetching tweets in real time, and then we are supposed to sift through those tweets and get the tweets that are talking about two specific people, and then take that tweet into a storage, right? And then process that tweet and then send it to a dashboard display and also send it to a sentiment analysis classifier, which processes the sentiments that are attached to the tweet and then sends it back to the dashboard. Now, the architecture we are using here is what is known as the Lambda architecture. Now, this architecture is principally designed for streaming data. So most of the time, when you're working on projects on your computer, you are always dealing with historic data, something that has happened in the past. You just acquire a CSV file and then you start trying to do some analysis or you start trying to build some model using that data. But when you're working with real-time data, something that is happening right now, it takes a whole lot of different approach. Now, the first thing is when you're dealing with tweets, you're dealing with big data, right? Now, when I say big data, I mean big in terms of velocity, in terms of size, right? According to statistics from statistica.org, there are about 500 million tweets tweeted every single day, if I still remember correctly. So if you divide that by 24, it should give you an idea of a couple of 100 million, about 2 million tweets thereabout. So you should be able to process a few hundred millions of tweets within an hour. Now, if you also break it down, it should give you an idea of how many tweets you should be able to process in a second. And then with that, you know that time is of the essence, right? If you're deploying a system like this in production, you don't have the luxury of wasting time, because for any second you waste, you're going to lose valuable data and you don't want that. So this is an index of what we have here. To be able to follow through, first to build this, you're going to need a couple of things which I'll explain later, but I'll try to explain each of these components here. So first is the Twitter API. Everybody knows Twitter. So, but for you to have access to real-time tweets coming from around the world, you need to register as a developer on Twitter and get access to the Twitter API. Most of all this we're going to see it in the demo section, but I just want to explain a little bit. So what we have here is Databricks. So Databricks is an interactive way of managing Spark clusters. So Databricks was built by the original team members that, you know, implemented the Spark technology. So if you're into big data, you should have heard of Spark, right? Spark uses clusters to run big data computations in memory really fast. So that is what we have here. So a cluster could have as many as 2 or 100 or millions of nodes, depending on the volume of tweets or the volume of data you want to process. So considering that the data is coming really fast, we want to have something that can process a large amount of data. And then the next thing we have here is event hubs. So event hubs is a cloud Azure native asynchronous messaging queue, right? So what it means is you can send messages to it, and then you could also fetch messages from it. It allows different parts of an application to, you know, communicate with each other, right? Without having, you know, direct connection in terms of code. So one part of your application is sending a message to the event hubs. Another part of the application is picking up those events and processing them accordingly. So that is what is going on here. And then because the whole idea of this project is to get this information as fast as we can to the campaign team. So we don't want to waste any time. As the tweet is coming, we want it to be as close to real time as possible. So the event hubs have the ability to ingest, you know, millions of events per second. So that is more than enough to handle whatever traffic is going to come from Twitter. So the next part is this part, right? When we aggregate these tweets and then count the number of tweets, how many tweets are coming from Mr. A, how many tweets are coming from Mr. B, how many tweets are coming for the both of them. And then we send that data to Power BI to display almost immediately, right? And then, so this part here from the Twitter API to the first Databricks cluster to the Event Hub to the Stream Analytics and then to Power BI is known as the hot path. So when you're dealing with this path, speed is everything. So in this case, we don't want, because any time wasted will mean that we will lose some tweets. So we don't want that to happen. So this part is going to process data as fast as possible. And then while this is happening, we also want to have this tweet sent to another Databricks cluster. Now, what this cluster does is that it's going to take each tweet and then try to see the sentiment of the person that sent that tweet. Try to infer the sentiment. So ideally, sentiment analysis is no longer a new thing. There are so many sentiment analysis tools out there specifically for tweets even. But Microsoft Azure has the cognitive services, specifically the text analysis cognitive services, which has the ability to analyze sentiments as well. So I also want to point out some things. When you're dealing with a production grade system that can ingest a lot of data, you should consider using some cloud technologies when you can that has some service level agreements that are reasonable. Now the reason for this is these technologies most times have been built for a very large scale. So if you have a situation where you have a technology that can do what you want, don't bother yourself trying to build it from scratch if you don't have to. Okay, so we could have built our own custom sentiment analysis model, but since we already have a model that does that in cognitive services, Microsoft Azure, we just use that. So that is what is happening here. So we take the tweet, we send it to the text analysis service. It gives us a score of what sentiment is on the tweet. Is it positive? Is it negative? Is it neutral? And then we get it back here and we take that tweet together with the sentiment and then send it to a different Azure Event Hub. Now this is different from this one. So this one houses the tweets and the sentiments attached in them. And then as these tweets are being fed into this event hub, this stream analytics job is fetching them as they arrive, right? So as it's fetching them, it's aggregating the results and then sending it back to Power BI. So you could see the tweets and you could see the sentiments attached to them. So for the first part of this demo, I doubt to be able to cover all this in great details as much as I want, but I want us to focus on the hot parts, which is because this is what most people don't understand how to do, how to deal with streaming data. So we're going to focus a demo on this first part that is going to deal with the streaming data as it is coming from Twitter. All right. So next part, we're going to dive into the demo.